All righty, good morning and welcome to our long coffee break series. Today, we're going to be talking about Innovent and air source heat pumps. I've invited Dave Milligan from Innovent to join us and go through this discussion. So at this point, I'm going to turn it over to Dave. And at the end, we'll give away a prize and let you guys know who's available or who won.
Thanks, John. Appreciate it. As John mentioned, we're going to be talking about our air source heat pump product line. My name's Dave Milligan. I've been with Innovent for almost 15 years now in the sales manager role. Have a lot of experience with refrigeration and custom equipment. Agenda really is to give you an introduction to the air source heat pump, the product scope, and then any complementary type of solutions, technology that's out there. Specifically, we're going to be talking about energy recovery. So up first is going to be who is Innovent, if you're not familiar with who we are. We are a custom manufacturer. We're based out of Minnesota. The big takeaway here is that as a custom manufacturer, we design the equipment specifically for your needs, for size, performance, or efficiencies, whatever one of those is your requirements. And along that line is our air source heat pump is a fairly new product that we're offering to the marketplace. It has a capacity of 6 to 126 tons. Ranging from 1 circuit all the way up to 8 circuits. And we've utilized a Copeland VFD compressor within this system. So each circuit is going to have one of these VFD compressors. And they are all rated currently for 454B. That's the refrigerant that we're going to be switching over to come January 1st of 2025. Along with this product, we've put on some Zeolabig condenser fans. And, these products also have our own controls because these are a little bit more complex than your typical air handler. And we'll get into a little bit more of the details here coming up. What we're seeing with the air source heat pump is that it's can be used in a wide range of climates, but as that ambient temperature drops below 0 degrees, you're going to need some type of backup heat or something that's going to be able to supplement it, because once the ambient gets below 0, it's not going to be able to operate. So you're going to need some type of heat, whether it's electric heat or if you're able to go to some type of gas or hot water, you can utilize that for when the system's down and you do need heat for the system. Also, what we found with these type of designs is you do need the air entering that AR coil to be about 30 degrees and above. It ties in really good if you're utilizing return air and the minimum amount of outdoor air. But if you're working on something that has 100% outdoor air and your ambient gets below 30, you're really going to need to either do some type of electric heat to help bring that temperature back up, or, as we're going to talk about a little bit later, have some type of energy recovery within the unit. As I was mentioning, some type of additional heat is going to be required, especially dependent on your climate. Colorado, I think the design is right around 0 degrees, maybe more on the northern side, it's going to be below 0, on the southern side, a little bit above. So you're right on that cusp. But we do recommend anytime you get below 45-degree ambient, you have some type of additional heat in the unit. The reason for that is as the unit's is running, especially in the heating mode, and we're getting down to those lower ambient temperatures, you're going to have that suction temperature in that condensing coil probably below freezing. So any moisture that is in that outdoor air is going to frost on that coil, and you need to be able to defrost that. So when that circuit goes down to defrost, you need something in there to make up the heat that circuit now is being off is going to need to provide that additional heat. So we strongly recommend using some type of electric heat coil because that gives you a lot more flexibility on modulating control. Or a type of hot water. What we don't recommend is going to gas because it takes a while for the gas to fire up and then start modulating. So we really recommend some type of electric or hot water. Now, as I was mentioning, this defrost, it's really in there to help protect the system. As the unit's in a heating mode, you could frost a coil. Like I say, it's not a potential, it's a feature. You're going to have frost concerns with these type of units. And as you can see, all that white is the frost that's built up on the condenser coil. And the way we are approaching that is we're going to take the one circuit at a time. So if you have multiple circuits on a system, we're going to take one circuit down and defrost that. What does that mean? We basically flip it back into a cooling mode so that we put all the heat back into the condenser coil to remove all that frost, let it drip down into a drain pan underneath, and then bring that unit back, or that circuit back up online. Roughly, it's going to take about 5 minutes for that to do. And then if the other circuit needs it, we're going to take that down for 5 minutes and run it in a defrost mode. So maybe 10 minutes, your circuits are going to be in a defrost mode. So that's when you're going to need that backup heat. Some mitigation strategies for this, obviously, is like we were talking about, some type of electric heat that's there to help provide heat when the circuit is going through a defrost cycle, maybe utilizing some type of recirculating air to help bring the temperature up in the air tunnel. And having multiple circuits is really a good strategy with these type of systems, because when you go into defrost, if you only have a single circuit, you're going to lose all your heat. And so you're going to have rely on the secondary heat. If we have multiple circuits, maybe if it's just 2, then we lose 50%, or if we have 4, then we lose 25%. So having the multiple circuits is really a good strategy with these air source heat pumps. The type of applications that we're seeing these being used for, really a comfort cooling and heating type of application is the number one area that we're looking at. Neutral air, where we're providing some type of room neutral, utilizing some type of energy recovery, that's another strong one. And then if it's just a heating only type of a unit, we could be using the air source heat pump for it. Areas that aren't as good, if it's a process application where we have to have tight temperature control, anything with a very high supply air temperature, something that's maybe 100% outdoor air without energy recovery. These might not be good applications for an air source heat pump. And, just in summary, real quick, again, capacities anywhere from 6 to 126 tons, ambient temperatures 0 and above. If we go below 0, we're going to want some type of heat in there to take on all the heating requirements for that space. We want to make sure we have mixed air temperatures hitting that coil at 30 degrees. So we strongly recommend energy recovery or some type of blending with return air and outdoor air, or some type of preheat coil. We're going to have defrost control on these things. We're going to want the different type of applications, really comfort cooling or DOAS type of applications. And we're incorporating this in what we are calling our E series, our energy recovery series, or our C series equipment that doesn't have energy recovery in it. And then along with the energy recovery, or along with air source heat pump, as I've been mentioning throughout, is energy recovery. It's a very strong product for us. It's something that Innovent really got its start in. Probably 2 out of every 3 units that we're shipping has some type of energy recovery on it. And you're going to want to take a look at it based on what your local codes and standards are to apply some type of energy recovery. But really, with this push going towards electrification, energy recovery is a great way to help reduce the carbon footprint and hopefully get rid of some of those carbon using heating devices. This is a great summary of all the different types of energy recovery that we've used within Innovent. We can get into more depth in this at another time. If you want a little bit more details on these different type of products, please reach out to your Long sales representative, and we can schedule some type of meeting where we can talk about it. But more specifically, what I want to talk about with the remainder of our time here is the AccuBlock product that's now out on the market. This is something that started in Europe probably 20 years ago, made its way to Canada, and now it's really coming down into the States. It's an ultra efficient, sensible, and latent energy recovery device. We've seen sensible energy efficiencies up to 95%. You really don't need any type of frost control in there like you would with maybe a wheel or a plate type of energy recovery. And because it has some desiccant that we can place on the media, it has the ability to reduce some of the humidification requirements in wintertime. And the way this really works is it's similar to any type of energy recovery device. We have two air tunnels. We have this media, which is shown here in the red and the blue. It's really a block of aluminum, for lack of a better term. The air, supply air, outdoor air, return air that's hitting these different blocks of aluminum, and lack of a better term, the return air is charging or heating up that block of aluminum. And after an amount of time, the dampers here are going to switch so that your air tunnels through the AccuBlock section changes direction or changes flow. And now the outdoor air is going to be hitting that block that the return air was charging and removing that heat. And that damper arrangement, the switch of the dampers, is happening anywhere from 20 seconds to 2 minutes. It's really dependent on what is going on in your ambient temperatures and your return air temperature differential. And that's basically utilizing some type of temperature sensors and a 0 to 10 VDC control signal to switch those dampers around. The dampers are an industrial grade damper, so with a gear driven actuator, so it's really flipping really quick and heavy duty design. As an example for this, to show how these units work, here's a system that's 10,000 CFM. We're going to compare both an enthalpy wheel and the AccuBlock. The wheel, we're utilizing an 80-inch diameter wheel in a nice round area. Has a certain square footage of media while it's spinning around. The AccuBlock's going to take up more of the air tunnel because I can fit that full space of the air tunnel, 94 by 94. I'm not leaving the corners like the wheel would for dead space. But you can see here the pressure drop. The wheel has a better pressure drop than the AccuBlock. But when you start getting down into the efficiencies, and that's where the AccuBlock really starts to shine. We're showing a sensible efficiency of 90%, a total efficiency of about 87%. And if you take a look at the supply air temperatures, that's really where you see the difference. With the wheel, you're only getting about 56 degrees off, where with the AccuBlock, you're getting about 64 degrees. And that 64-degree air going down into a space, might not require heating right within the unit. You could have VAV boxes or something down in the space, that radiant floor heating or something along those lines, that can make up that difference of, 8 degrees or 7 degrees to get it up to that room neutral. So that's some of the stuff that we've been seeing, is maybe utilizing that AccuBlock might not require a heating element in the unit, but it all really depends on your area. Really, to summarize our discussion today, the air source heat pump, it's a new product out on the marketplace. It's really addressing a lot of this electrification requirements that we're seeing all across the country coming up. We can go from 6 to 126 tons, ambient temperatures 0 degrees and above. Really, a wide range of applications here for comfort cooling, DOAS type, utilizing our E series, which are our energy recovery series, or our custom series. Really, what we would like to do is, if you come across an application, reach out to your Long associate, the sales rep. We can work together with you, with them, with us, to talk about the system complexity, to work through control issues, just to make sure that we have all our bases covered. Again, if you have any further questions, please reach out to Long, and they'll be able to help guide you through some of these questions. John, back to you.
All right. Thanks, Dave. I really appreciate your information today and taking the time to share with us a little bit about air source heat pumps and the AccuBlock series. So next week's meeting is going to be with Jeff Rodell, will be the presenter. He'll be working with Ruskin regarding airflow measurement. And also, I think he's going to also talk a little bit about our selection software that's available to our consultants. Look forward to seeing you guys next week on our next long coffee break series. Appreciate it. Have a great day.